we will talk about the role of reproductive technologies in helping achieve genetic progress. So we talk a lot about genetic progress today, and there's a marketing part of that, which is the front end and the back end of today. And Valerie's been talking about, sort of the research part of reproductive technologies, like how do you figure out from the genomics point of view. And so I get to introduce, and Dave will finish off also on some of just the reproductive technologies that we can use to achieve some of our goals. This is, maybe I'll just move this up a little higher. I turn my head. This is kind of the standard formula. Gary, can you hear me if I turn my head? Yeah, it's all good. When you talk about making genetic progress, it's the accurate selection by, or multiplied by, selection intensity multiplied by genetic variation and divided by your generation interval. Like that's been in textbooks since the 50s and 60s. Often you'll see the first part is heritability. And when you see those and you think about that, that equals genetic change. So one of the big drivers... One of the big drivers that will change that formula a lot is generation interval. Maybe I should just use the hand.
Turn it off.
So a little more awkward. A little more awkward, but hopefully better sound. Okay, so one of the things that drives us obviously is generation interval. And as we can get some of the generation interval down, you can see some of the topics from today really kind of fly in the sense of, okay, what can we do to use some of our reproductive technologies? If we want to increase genetic change, we need to pay attention to heritability. We need to stay focused on what we want to select for. We have greater abilities in the traits that have more variance to be able to select and make progress. But a lot of that is driven by generation interval. And then you go, again, both on the female and on the male side, right? So what tools do we have? We have AI. We've used that for a long time on the sire side. Sex-selected semen allows us to use AI on the sire side and increase the amount of females, because that can generate the next generation a little bit quicker. Conventional embryo transfer using selection on both the female and the male side, and then IVF technologies. And these two both would fit that formula in terms of being able to sometimes drive down that generation interval, but number 4 would allow you to do that a little bit quicker. And of course, both of them, you can do that on the sire side much more with increased heritability estimates from the genomic sires, right? Okay, so here we go, talking about embryo transfer. And I'm going to flip through most of this presentation fairly quickly and give you an introduction and talk a little bit more today and give you just a really wide, quick introduction to the IVF technologies. All of them, like, are tools that you use on the farm. I mean, you guys are familiar with a whole bunch of them. On the embryo transfer side, I mean, very many of you are familiar with some of the positives and some of the good news, opportunities, disappointments that come with, using that consistently on the farm. And we're going to introduce IVF technologies and just some of the process that we do on a day-to-day basis or on a week-to-week basis to make that happen. And so if we get to number 4 here right away, it's IVF, and technically it's the Latin for in the glass, or for today it's mostly in the plastic, but fertilization occurs, and an entire day 0 to 7 is under lab control, right? So all of those little things that have to replicate what's happening off of the ovary and the oviduct and in the first part of the uterine horn is now having to be replicated in plastic and trying to mimic those conditions. And just understanding, at least at a basic level, what some of those challenges are, help us to see, what can happen, what's been achieved, how do we apply that, and then seeing that for all of the stuff that's kind of intricate, which gives us a sense of wonder, if you will. There's also many things that are very applicable, and we can use those technologies very quickly today, knowing that, there's just a lot of science that's behind it at this point. So we'll just flip through like what's going on the cow side, what's going on the sire side, and what's going on in the lab, just to give you an idea what goes on with all of that. Here I've talked about mostly what the event is, right? So when you come to the farm, there's always like flush day. That's the big event. And so you're doing all the shots, you're doing the breedings, and then someone shows up, you flush the cows, and that really works well, and that's kind of your big day. And now the event has changed a little bit to being OPU day. And it really doesn't tell you very much other than the number of oocytes or potential embryos you have, and you love that number to be large, of course. But it changes the sequence of how all of the events go. So now you're PGing the recipients all at very much the same time, but instead of breeding the donors and then waiting the 7 days and letting all of that under the plastic work now occur naturally inside the cow, we're now taking those oocytes out, and you'll notice the donor does not get PG'd in this case, and we'll go ahead and take those oocytes out and put them under a maturation media for 24 hours, and then fertilization occurs in the lab. And then transfer day is 7 days after that. All right? So what's in vitro fertilization in a nutshell? I mean, we're starting off here. So here's the oocyte, and it's sitting inside a follicle, and you see some pictures of that. We're coming in with a needle and aspirating all of this fluid out and hopefully taking that oocyte with it. We like to see the cumulus oocyte complex around, this group of cells around, and some tight, but hopefully with some consistency and starting to loosen up just a little bit. And as that maturity happens in 24 hours, and this for us occurs in the incubator in transit, it's ready for fertilization in 24 hours. It's exposed to the sperm for about 18 hours, and then hopefully you get cleavage, like that first fertilization, that first cleavage of 2 cells, and then development for the 7 days. And we'll show you some embryo pictures along the way too. Okay? Let's start talking about the donors a little bit. And so here we have a nice show heifer, and my only point is, like as in your other donors that you use on the traditional embryo transfer programs, sharp and show shape is really kind of nice for pictures, and all the rest of it, but probably not ideal as a donor. And so we just want a little bit more condition on her. This is a young heifer, but she's carrying some weight. She's at least a body condition score of 3. If you need to take pictures of these for marketing purposes, do them when they're 5, 6, 7 months of age, when they're nice and sharp, and then we need to put some weight on for them to be successful both on the IVF side and on the ET side. As far as donor management goes, it's really all of the things that apply to all kinds of reproduction, embryo transfer. The same rules apply on the IVF side. And we probably just become more aware of it because we're pushing the envelope on the age side, right? So when we're normally doing embryo transfer on heifers at 12, 13, 14 months of age, now the push is we want to do these heifers at 8, 9, 10 months of age. And so we have to get them reproductively active quicker. So obviously you want energy levels up, you want it to cycle quicker, they still have to grow, and of course we want to pay attention to mineral levels in that whole game too. Just to show you some of the equipment we use, here's a probe that goes into the vagina. What you'll see is this probe is fronted by a small convex ultrasound, and you'll see here a needle. And so this is ultrasound guided needle aspiration of the oocyte. And we can just move this little slide back and forth as we need to. We have a pretty good idea where the needle is. We can replace the needles between donors and all the rest of it for biosecurity, leukosis control, all of those kind of things that we got to watch out for too. And this connects to the ultrasound monitor, and this of course is in a warmer. One of the things we really got to watch on the IVF side is really just keeping everything as warm as we can all the time. Okay? In a schematic, you'll see an arm go in, take the ovary, bring it right next to the cervix so that the ultrasound guided needle will move right next to the cervix to the left or to the right and puncture through the vaginal wall, and then be able to aspirate some of the follicles that you see. Okay, so here's a heifer, and here's kind of everything lined up. You see she's a little bit heavier than the other red heifer that we pictured, but the machine is basically, the probe is here, and the lines run through here. This runs the vacuum pump that is connected to the tubes that are in the warmer, and those will be on me. And once we warm this up, we're sitting in a warm room here, which is usually 75 degrees or so, and the window runs across there to a small lab. Same thing here in another warm room we have. Here we have a larger cow, but again, she's in good condition without being fat. We do play around with ways to keep them comfortable. We find that these little things, and whether you used to watching cows or listening to Temple Grandin or all the little things, we try to play around with cow behaviors to the point where we want them to settle down. The more they dance and the more they feel uncomfortable. There's only so much chemistry can do in terms of giving them a little bit of romping to settle them down. We find out good footing and making them feel secure does help. And when you're trying to play with a needle and hit a follicle, those things just get to be really important too. So, you know, I've already showed you the range of who we work with, you know, some older donors, and Dave will get more into this. Here's a cow that's, you know, made some all-Canadian winners, and so offspring from her are just as valuable as they would be. Logistically, you know, you see here that we're really in up to the armpits and into the probe a really long ways on some of these older cows, but still very, very possible. On some of these younger heifers, it's almost the opposite, where you're looking for room to move on some of them. But in both cases, if you are patient, it usually works fairly well. You'll see the warmer, the tube is actually connected to the warmer, so the aspiration of the oocyte fluid or the follicular fluid goes into the warmer there, and this gets connected to the vacuum pump, and that kind of works. 3 quick slides here, not to do a lot of animal physiology for you, but what we really are interested often is also increasing or maximizing the amount of follicles we have to work with. So you know that ordinarily you always have these follicular waves come through on the ovary, and these things occur in every part of the cycle all the time, right? And so we're just trying to pick them up at a point where we can maximize or pick up a wave when we're normally doing that. And so often we have to manipulate the dominant follicle, because when we can manipulate that one, that initiates the start of the next wave. So in this case, we do it 2 ways. One is called ablation or DFR, and what we can do is just go in with, again, the ultrasound-guided needle and take out this largest dominant follicle. And we'll generally take out 2 or 3 if there are that many large ones. And we know within a day and a half or 2 days, we'll initiate the start of the next follicular wave and be able to play with that. If we don't have control over the donors to the point where there's sometimes in and out donors, we'll do that with estradiol, and by doing that, take out the dominant follicle, and in that sequence, the interval's a little bit longer. We're 4 days away from beginning with FSH or full Trogon. But what we're gunning for is that next wave emergence, because if we can catch that wave and stimulate it, that'll tend to maximize the amount of follicles that we can get from that donor. And again, listen to this in the context of, you know, we already talked about nutrition too, and all of the rest of the things that have a huge impact on the number of follicles that are available. So this is kind of what we're looking for, and then we'll see this on the ultrasound. So now what we'll do is we'll actually see these follicles on the ultrasound, and the needle will always come in at about 1 o'clock here. And I think we got this down, and Kristen's going to show you. And so here the movement is basically my hand, and you'll see the needle come through there, right, and pick into some of the follicles, okay? And so when that happens, and it should be this one next, and then you see it collapse, right? All of that fluid is just aspirated out of there. You see the needle behind this one next. You'll see me hit it. I'll miss it. I'll miss it again. Oh, there it goes. Okay. So, and there it is. And then all of that fluid is taken out. It winds up in the warm pouch right next. And then from there on, stays warm and goes to Gwen and Paulette in the lab.
Cool. And you get paid for that?
Yeah. That's true, John. So, you know, the same thing we're looking at all the time. So then it goes to the lab, and here's Christine and Gwen working on doing the searches. So you can see the equipment that's involved. There's a lot of it, but it stays on warming plates. We keep the rooms warmer than normal, and use the warming plates all the time. Everything that pretty much touches from, you know, the warmers over here to having the incubators. There's much more pressure on making sure nothing's cold shocked on the way through. Okay, and what they're looking for is basically oocytes. So here's some denuded oocytes, and here's some with the cumulus oocyte complexes, this group of cells around, and you'll love to see that group of cells around. These are the ones that tend to give you better development into fertilization and then into embryos going forward, right? It's not that these won't work well, and when we package them, we'll tend to package some of these together so that these cumulus cells can also have a positive effect on them in terms of the maturation part. Okay, so then what we have here is we have an incubator, so on the oocytes that we recover, we'll put them into the incubator, and this is a microprocessor controlled incubator that then keeps the temperature extremely consistent, and that's really what we're after. It also goes in what we call IVM media. So the media is designed to mature it en route, so that when it's being done by FedEx and it winds up in Quebec, that we are actually doing the first 24 hours of the process in transit. Ordinarily, if we would do this in our labs and sit here and do the IVM, it would just be sitting in our labs being warm. In this case, we can use the incubator to actually do that job with the correct medias, right? Okay, and there we are, and there they are, and it's a long ways. Okay, on the other side, there's the semen side, and again, it's reasonably simple and reasonably complex. After the oocytes get over there and they're in IVM for 24 hours, we'll thaw the semen. Then it goes through a Percol gradient. Basically, it's sort of gets rid of a lot of the debris and the dead and inactive cells, and it runs through a density gradient, so that at the end you wind up with a pellet of semen at the bottom, which is the most active, and that's the good stuff, and that generally gets used in the process. Here's an incubator, and these are the wells that are inside. You'll see the plate in here. So with the oocytes now through the IVM process, or they're ready for fertilization. The semen that's gone through the Percol gradient and is ready for fertilization, we put them in here, close the lid, and when it's dark, stuff happens. Okay? This is what we don't have, and this is one of the reasons why we cooperate with Bovitech and CMIS on the side of it. This is well over $500,000 worth of equipment, but this is the sexing equipment that's used, and when we're looking for oocytes, we really want to be able to take advantage of this technology. So there's two kinds. I mean, you can buy your sex semen, and then the other thing we'll do is we'll work with reverse sorted semen. With reverse sorted semen, you can use the best semen out there, the stuff that's not sexed normally. Like nobody has ever sexed Goldwyn semen, but you can use Goldwyn semen on your IVF donors by using that semen and reverse sorting it. And so the semen is then thawed, and it runs through the sexing process, the same as all of the semen that would normally use for sex selection, and then be ready to move to fertilization. Ironically, reverse sorted semen works better than sex semen. You'll actually get better cleavage rates if you collect the semen, freeze it, thaw it, reverse sort it, and use it, than if you actually collect the semen, sort it, freeze it, and then want to thaw it to use it. And why, I really don't know, and neither does anybody else, so it keeps us humble. Okay, then same process goes into the incubator. You close the lid, it gets dark, stuff happens. Okay, and what comes out of that is mostly this. So here we are with the embryos being day 5 morula, starting to turn into a blastocyst here. Here's the blastocele for an expanding blastocyst, fully expanded with kind of a thick zona. You'll see the zona thin here, and you see the breach on the zona here as one ready to hatch, and here's one that's already hatched. But those are the stages that we'll find in this whole process, obviously. We do have a lot of variation in stages when the embryos are collected, and the same thing occurs in the IVF process. That does not change that much, and so somehow you have to manage this as the days go on. Also, when you'll wind up with some day 5s and some day 7s, and have to make some calls, which are tough enough when you're at home with a range of recipients, but sometimes when you're working long distance like we do with Quebec, then it makes the job a little bit more difficult yet, but with a good attitude, everybody gets onto it pretty well. A really nice IVF blastocyst, and one that's not quite so nice. You see a lot more granular. You see a lot more definition between the cells. The junctions aren't quite so tight. Used to wind up with a lot more. This used to be a classic 7-1 IVF embryo, and with the improvement in medias, we're getting a lot more of these right now. And as that improvement in medias has happened, so has our improvement in technologies. Okay. One of the things that's really improved with the change in the embryos that I showed you between left and right is our ability to freeze. And so that's one of the other reasons why we work with Bovitech, in the sense that they've really got a handle on being able to freeze these #1 embryos with more success than we historically have been able to. And for those of you that like science, I mean, basically most embryos that you see are like grapes. And of course, at -5 or 7, we put them in ethylene glycol, which is a cryoprotectant. and then we freeze them down very, very slowly. And what happens with that is that as you increase the amount of ice, you increase the amount of salts that are left here, which continues to draw out the fluid, and it winds up being frozen like at -30 or -35, like a raisin. And you want that process to be as gentle as possible, and that now is more possible with IVF embryos with better success than it has been. And the big change was only like 2-3 years ago. Okay? And a lot of it is because that a lot of the old protocols were basically one culture system from day 0 to day 7. And this is exactly like the embryo that we showed about 3-4 slides back. Right now, they're staging it, and they're basically mimicking some of the events that occur in the oviduct, but also now changing it to the part of compaction and the part of expansion and hatching. And by running it into 3 separate medias with slightly different criteria, been able to produce an embryo now that's what they would consider a new IVF embryo that is much closer to what we're used to looking at on the in vivo side. And so as this embryo is changing, we've just got better quality. We've also got better freezing abilities. Okay, and here's a slide from Bovitech that shows some of their results. And some of these pictures are all like just laboratory results where they're actually just showing them in culture. But they're also running up with real pregnancy rates based on frozen thaw, and these are repeatable. We wind up with these results over here. The freezing results and the thawing results are going very, very well. We're really careful also about what we do. Like we talked a lot about, keeping these things warm from start to finish, and even now when we do the fresh transfers, we'll continue to use the gun warmer. Used to an AI gun warmer, we actually run it up 3 degrees and label it IVF and use them that way too, just to try to get another measure of control. So what we do generally right now is on Wednesdays, like this morning, we'll do the OPU, like we'll do the open pickups. And as we speak right now, they're picking up, the courier's picking up that incubator, and it'll run overnight to Quebec tomorrow. And what's happening right now also is Quebec's loading up last week's oocytes that returned in embryos, and they're on their way over here, and they'll arrive around 9:30 tomorrow morning for transfer. So that's kind of the system, the chaos of the system, but even so the repeatability of the system. A lot of the decisions get made on Wednesday morning in terms of what will come and what will stay. And generally, with the amount of recipients we have here, most guys are really quite stretched in terms of being able to put them all in. And with the ability we have right now with the recipients at WestGen, we've got an expanded recipient pool that we can now get more of these embryos over, which has been a real boon to us in the sense that we just can't freeze them all. And so the ones that do come over here are the 2s and 3s in general. So a lot of the ones that we put in fresh are 2s and 3s, and a lot of the ones that stay over there will be frozen for transfer at the owner's farms going forward. Okay. Last step, but not necessarily, is the recipient transfer. And the thing is, on IVF, it doesn't really matter. The rules are the same. Got to do a good job with the recipients. Got to do a good job with heat detection. So everything's about being well grown for their age and gaining weight on a balanced diet, and making sure that the heat detection is spot on. I'm just going to do one quick what's new thing before we finish. And so some of you have heard about some of the work that's been going on with actually doing genomics on embryos. And so there's some challenges to this, but just so you know that the science is there and it's actually working. Normally we would pull hair and we'd have lots and lots of DNA. When we only take a biopsy, and this is the same as you would when when some of us have sexed embryos for a long time, in the sense that you take a small biopsy. If you're looking just for XY, it's as simple, but if you're actually trying to run a whole genomics panel on it, you need a whole lot more DNA. And some of their amplification process in order to get a lot of that, in order to run the panels on them, has been a science and a research project in itself that is a real interest at Bovitech Quebec, and they've really made a lot of progress at it. And I thought I'd pull this one in. A lot of it is because this might be of interest based on what Valerie was probably talking about this morning, or we talk about how do we run our own programs for genetic progress. And this is kind of the humility slide, or the genetic variance slide. And these are genomic results from different flushes, same donor, different sires. These are the PAs that should happen, and the variability between some of the offspring. So if you wonder why your full sib isn't quite as good looking and intelligent as you are, like this is how, this is the math as to why that works. And so for us, you can see the resources that it takes. I mean, Denise and Lorene, they spend a lot of time on the marketing side. Lorene spends most of her time in communication. And Paulette, myself, Gwen, and Christine, when she's not taking care of baby right now, run the labs. And it just takes that many people to do it. Our veterinary team, sometimes they're running around doing the pre-checks on recipients and all the rest of it. And because we did this late, I don't have Katie and David's pictures on here, but you'll see David really soon here, and Katie is looking very sharp, and so you'll see them both here today too. But it takes a lot of people to run a good team when you're doing all of this sort of work, and competent people to really go the extra mile a lot. So we're really fortunate in terms of having a good resource base to pull some of this off. And then, now David.
So good afternoon, ladies and gentlemen. First of all, I'd just like to thank the workshop for inviting us here this afternoon. It's a real great pleasure to come and speak to you. What I'm endeavouring to do this afternoon with my presentation is put over a little bit, answer one or two of the questions that I believe you guys probably have on the IVF process and what we do. It never ceases to amaze me that the IVF process has been very much about education for us to achieve the results and move forward with this business. So I will progress a little bit with this. So history shows that the evolution of the bovine genetics industry, great leaps have always been made forward, but always been met with concern. We've had things, what seem simple to us today, such as artificial insemination and embryo transfer, and in their day they seemed positively revolutionary and always gave great concern. But today they are taken for granted as being part of our industry. And today there is a new revolution, and that is IVF. It's on your doorstep, and it's here ready to be used. So what would the reasons be to use the IVF process? There are various different reasons. Firstly, the interval, the speed of genetic gain. We can do collections every 14 days, and that is quite successfully. We also have the ability to do collections on the pregnant cows. As a rule, we can go up to 100 days collection, but it very much depends on the access of the ovaries, and I've personally seen a cow that's been collected up to 150 days, but very much depends on the access to the ovaries. The younger age animals that we can do the collections on, we are constantly doing them around the 8 months of age now. It very much depends on one, the heifer's development reproductively, but also on the heifer's development structurally in the pelvic cavity. Another reason is frozen IVF embryos can now achieve comparable pregnancy rates to conventional. As Rich has just been showing you, it's very much the case that in years gone by, it was very easy to see the difference between a conventional embryo and an IVF embryo. These days, it's a lot more comparable, and in quite a lot of cases, you can hardly tell the difference. Rich has gone over the reverse-sorted semen. This maximises female creation from sires not typically offering sex semen. But the other thing that it also does is the reverse-sorted semen can eliminate the need for the biopsy to verify the sex, and so take away that little bit of intrusion from the embryo. Also, cows producing many unfertilized embryos via conventional ET, often achieve better results with IVF. And in a little while I've got 1 or 2 case studies to show you, and they've been chosen for various different reasons, not just to show you the cost of IVF, but also to show you some of the donors that we have been working with and what we've achieved with those cows. So customer profile, this was another one that I believe people have maybe a preconceived idea. I mean, the history of the IVF procedure has depicted that the reputation for the technology is reserved for that very elite animal. This was partly due to the cost and the availability of the procedure. The cost now is continually decreasing, and as for the term the elite animal, there are many ways to define that. I know in our barn at Milner, in our resident donors at this minute, we have got the wide variety of donors, whether it be a pregnant heifer from somebody's herd, from a really good cow family that you guys will not have heard of, but to him it is a really great animal and great cow family that he's developing, to those big old show cows and those very high profile genomic heifer calves. We have quite a wide span of animals that we deal with. And also, just the availability now for you guys is right on your doorstep, with one of only 2 Canadian IVF facilities right here in BC. So the customer profile is whoever sees the future, sees how to take their genetic business to that future goal, and with that sees how utilising IVF can take them and get them there. Now, I don't profess to be the genius on PowerPoints, but this is my little interaction to liven it up. The next section I call Myths and Legends, and we hear lots of talk about some of the problems that have been with IVF in the previous years when it was first being developed. Early work was met with its challenges. They had large calves, questionable success in freezing the IVF embryos, water belly calves, and those first 3 there have all been very much addressed, as Rich said, with the change in the media and the growth of the embryos in that media and at different stages. Also, questionable donor fertility after collections. I feel that one of the things that we do is that we track the donors that get bred back, and we very much hear back any negative things, and I know we have donors at Milner in the resident side that we have to get back in calf before they go back to the customers, and the results have been very positive, and we've been very successful at getting those cows back in calf. So the development in technologies have eliminated many of these issues. So Rich has gone over some of the research and development, and I think I just wanted to say really it's Western Canada's fortune that we have this access to this groundbreaking research and development, and that will lead to an exciting future for here in Western Canada. I mean, us guys, we hear some of the things that they're working on. They're not accessible to everybody to hear what they're working on, but you know, they're always striving to make it better and better for you guys. So the economics, reduction in cost improvements in all aspects of the IVF process make IVF an option for a wider variety of donors. It's not just the problem cows, it's not just the elite cows, it's there for everybody to use. So when I went forward, just before Christmas, I put 4 case studies together, and I very much chose these for various different reasons. First of all, they're not the best cows that we've done, best results we've done. They're not the worst results. They're a medium result, and they very much show the options of the problems that we can have with the cows that we have to overcome, and some of the age thing. And finally, it gives you what it costs to produce each embryo on the process that these 4 animals did. The 2 things that I didn't take into consideration, which I considered variable costs, were the price of semen, because that can be very variable and would be a cost at any time on any program. And the other one is implant fees, because sometimes these embryos go back to the farm, we don't know how much they're being charged. So what it does take into consideration, and all 4 of these donors came as resident donors, so all 4 costs include the housing of the animal, various different costs within it, including some embryos going back to the farm and some being implanted at Milner. But like I say, no implanting fees were put together. So case history A, this was a donor that came in at 8 months old. She had 8 collections by 1 year, 2 days. And in that time she produced 71 embryos. So no reverse sorting of semen was used on this heifer. She was a genomic heifer, and so reverse sorting was not needed. The average cost per embryo, not including semen and implant fees, but including housing, $157.23. Donor B, this was a maiden heifer, 15 months old. She did 4 collections with us. She produced 29 embryos. Again, no reverse sorting of semen. The average cost per embryo, not including semen, was $211.49. Then we move on to 2 of our geriatric girls, 2 older cows. Donor C, she did 2 collections, produced 17 embryos. The age of the cow was 13 years. She had a fused ovary and so could not be flushed conventionally. And within this price, reverse sorting of semen was carried out, so all the embryos were sexed. The average cost per embryo, not including semen, $332.23. And then donor D. This was another older cow. She was 13 years, 4 months. We did 4 collections, got 20 embryos. She had a history of quite a severe uterine infection and lots of unfertilized embryos. Reverse sorting again was carried out, and the average cost per embryo, not including semen, $229.10. So that just gives you a little bit of idea what the cost of producing the embryos are. And again, I will tell you, we've had better results. We've had cows that have done nothing. They are all out there. Whatever you see, they will be out there. But they were chosen as in-between models, so I hope that gives you some insight. And so our pregnancy checks. We've now developed great consistency in our preg checks. As with any breeding policy, you have your disappointments. Since we moved to our hybrid trial, we've had a low of 44% and a high of 75%, but we consistently average over that 50%. It's very often around that 50-52%. And what we're putting in here on these figures is very much the number 2s and number 3 embryos. It's very rarely we put a fresh number 1 in. We do occasionally, if the embryo has been sent back to us and has matured overnight from a 2 to a 1, then they obviously go in. And as you will see, as with all reproduction programs, trends not seen can be seen, whether it be, sometimes old cows versus new cows, a family that, we get really good peg rates with, and then family that we don't get such good results with, and then freshly frozen. And I was a bit low to put this bottom one in, the freshly frozen, because although I quoted that we average around 50% on our peg checks, and that's on fresh embryos, we are just currently running around that 60-61% on frozen IVF embryos put in, and the results that we have back from the field are very much equal of that, and people are really happy with the frozen eggs that they get. The criteria that Tech put on freezing those eggs back in Quebec is very, very strict, and that's what gives you such a good product. So to conclude, there is a business here in Western Canada now that will create and provide every bovine genetic business the opportunity to step forward and to achieve a new goal with new technology, but also to develop in every area they feel their business needs to move forward to help you guys. So I hope I've given you a little bit of insight, and I know Richard's going to join me back up here, and if there's any questions, then I'm sure we'll be pleased to answer them. Thank you. That's it. No questions? Well, you know what? One thing I would say that, you know, if anybody that has any questions, you know, we're both more than happy to, not just today, but any day, you know, give us a call if you've got something that you need to discuss, you want to, you know, some ideas about whether it's improving something or questioning whether something is working right for you, you know, don't hesitate to ask either of us. I mean, we're more than welcome to help. Yes?
Rich, I was going to ask you, are you seeing more herds do this who historically have not, becoming more mainstream for more like commercial herds?
Well, especially over the last year, Steve, like, you know, we've had 2 years of this, and we've had some hiccups along the way in terms of, you know, applying the research. We, you know, have the ability and have used the ability to do everything in like our own labs and all the rest of it, but we want access to the reverse sorting, we want access to the improved media improvements that Bobitech has done. We've been talking to them for 3 years, and you know, slowly over time we're, you know, getting to the business model part of it. But in the meantime, you know, we have to be out on the street doing the cows too. And you know, we're all normal. Like some guys will, you know, take it and take the risk, so to speak. And we had some partners with us that were willing to take the risk and, you know, do the first ones. And so as everyone hears about, you know, like, oh, they did pretty well, and you see some of the success stories that Dave showed too, you know, it just gets a whole lot less scary. Nothing guarantees success, whether you're, you know, breeding, you know, all of those ABCDs, you know, all of them have their risk of failure. But on the other hand, you know, what's becoming acceptable risk now, you know, like we can say to you, look, we can do those cows, we can get, you know, 10 to 20 oocytes from them, we can bring you, you know, 4 embryos, we'll get a 50% preg rate on the 2s and 3s and a 60-65 on the 1s. You know, those kind of things we can tell you with more surety right now. And, you know, hey, that's as good as it gets in lots of, you know, reproductive programs around. So yeah, it's much less of a scary big black hole. One thing I wanted to do, and I can do this a little later too, was when I touched on the bulls for a minute, I probably should have told you a little bit more. But a lot of the semen that we use, it actually has great variability. And so you can get a bull that is historically kind of scary on the conception side, like a gold one, you know, you don't use them that much on in vivo because, you know, his conception can be so bad. It's actually awesome on IVF. You know, he does a really good job. And then you can have other bulls like Winbrook. Nobody even wants to use them on IVF. We say Winbrook, and Bobitech says, no, don't think so. You know, so not to, and just to show you without, and by naming names, but it doesn't really matter, right? There's a range in the bulls you can use, and we need to bull by bull just assess how their semen also works in IVF systems. Like it's a uniqueness all its own too. So when you go through the planning process and you're talking to Dave or Lorraine about which bulls should I use, sometimes you don't get the one you want, and you have to work with the other breeders of the day to sort of maybe get to your top 3 and then work through that. But in general, you can get, you know, the group you want for sure.
Yeah, I was just going to say a little bit on that. Like I touched on in my presentation, the one thing that has been very, very evident is to get the education over. The calls that keep coming in are coming more and more often, and more diverse clientele, even if they're just inquiring about the IVF system and what it can do for them. But the more we educate people, the more those calls keep coming in, and the more progress that we make. Paul Meyer.
Just a question: when you collect or do an OPU, what typical number would you harvest, and what percent go on to become actual viable?
Well, I don't know whether Rich wants to answer this, so I can answer a little bit, and whether he wants to add to it. But obviously, as with any genetic process, whether it's conventional embryo transfer or IVF, it's very much comes down to the cow a little bit on numbers. But the one thing that from the we received a report back on the what has happened with the oocytes, and I work very much on the basis that from the number of oocytes that are produced, we probably get about 50% embryos back, and about 50% of those embryos are freezable, and it's not set in stone by any means, but it works as a rule of thumb, and I mean, there's so many variables that affect it, so.
Yeah, and you hate to always say it depends, but it does go back to, you know, if she flushes really well as an in vivo, like she tends to make more oocytes for that process too, even if she doesn't fertilize any one of those, like historically a problem breeder. Those are the ones that, you know, we'll collect most oocytes from too. You know, we're working a lot with young heifers right now, and for a lot of them, a lot of it's conditioned, like they have to be putting on weight, they have to have some cover on them. If we get them come in that are very thin, we'll be down to 4, 5, 6 very quickly, and watch their numbers go up progressively as they get on the right feeding program. So, you know, we all have to do our part, and it's never one simple answer, but we're always targeting for, you know, the 10, 15 oocyte range, and hopefully we can get that most weeks. And some weeks we do, some weeks we don't. We've done some real challenges for problem cows, and, you know, we haven't got, you know, huge numbers off of some of them, but we've got pregnancies off of some of them, and to say, well, that's a viable program, no, it's not. But the owner wanted some more progeny from those specific cows, and, you know, we help them meet their goals. So, but in general, it's coming to a point of the 3 groups, right? The very young group, the pregnant group, and the old group. You know, and there's other cows that are in that system, and you recognize too that by being able to do them every 2 weeks, there's some advantages to just even doing open cows that would even be considered for in vivo at other times. But, you know, in order to do those 3 groups, you don't have a lot of options. They need to go into this kind of a program. And not only that, they work really well on this kind of a program, so it's a really viable option for you to look at.